Welcome back to Code Warehouse. Today's LeetCode DCC question is even or tree. This question has been asked by JP Morgan 3 times, Bloomberg 1 time. Let's read the problem statement. A binary tree is named even odd if it meets the following conditions. So they have given 3 conditions, and if the given binary tree satisfies these 3 conditions, in that case we have to return true, else we have to return false. Let's see the condition one by one. The root of a binary tree is at level index 0, its children at index 1, and so on. Second condition says for every even index levels, the values at that level are odd and are strictly increasing from left to right. Third condition says for every odd indexed levels, the values are even and strictly decreasing from left to right. Let's take this example and understand the question. So in this example, we can see the first root node has level 0, which satisfies the first condition. And also it is given, since the level 0 is an even index level, so the values must be odd. So we can see this value is odd, and the value must be strictly increasing. So since we have only one value in level 0, so we can say this is strictly increasing. In the next level, level 1, so this is odd. In this case, the values should be even and strictly decreasing. We can see 10 is even, 4 is even, and from left to right, it is strictly decreasing. 10 is greater than 4. In level 2, since it is an even level, the values must be odd. So 3 is odd, 7 is odd, 9 is also odd, and it should be strictly increasing. So we can see 7 is greater than 3, 9 is greater than 7. So it is strictly increasing. And again, in the next level, level 3, since it is odd, the values must be even. So 12 is even, 8 is even, 6 is even, 2 is even. And it should be strictly decreasing. So 12 is greater than 8, 8 is greater than 6, 6 is also greater than 2. So we can say all the 3 conditions are satisfied by this binary tree. So in this case, we will return true as the answer. So we can see the value returned is true. So we will take these examples and analyze the approach, how we can approach this solution. So let's see example 1. So the approach we are going to discuss in this, we don't need to handle any edge cases separately. By this approach, we will be able to handle all the test cases or any edge cases itself. So what we are going to do? So since we have to satisfy the conditions level wise, so for odd level and even level, the conditions are different and we have to satisfy that conditions level wise. So we will traverse the tree in level order. So we will traverse the tree level order. That is, we will first visit all the nodes at level 0, then at level 1, then at level 2, and then at level 3. And for that also, we will take two queues, one for odd level, another for even level. So in this queue, we will insert all the nodes which are at odd level, and we will insert all the nodes which are at even level. So initially, current level is 0. So at level 0, we can see the value is 1. So the value should be odd. So we will first check if if the value at this even level is odd or not. So we can see 1 is odd. So, and after that, we will see whether that one value is greater than the previous value or not, since we have to follow strictly increasing. So if we put 1 here and we can see 1 is greater than previous value, so we will update the previous value and we will insert the children of this node in the odd level queue. So, so left children of 1 is 10. So we will insert 10 here and right children is 4. Now we will pop this node. So we can say now this even level queue is now empty. Now we are at level 1. At level 1, we can see the first node which we got is 10. So we will see whether it is strictly decreasing or not. So we can see 10 is less than infinity. So it is satisfying this condition. And at odd level, the value should be even. So we can see 10 is even. So now we will push the children of 10, left and right children, to even level queue. So children of 10 is 3. Left children is 3. Since we don't have any right children, we will not push anything. So now we will pop this node. Now we can see the next element is 4. Since we have seen 10, so we will update this previous value with 10. Now we will see 4, whether 4 is less than 10 or not. We can see 4 is less than 10 and also 4 is an even number. So it satisfies both the condition. So we will pop this element and insert the children of this 4 into even level queue. The children of 4 are left children is 7 and right children is 9. Now we will pop this and we will update the previous value with infinity. Now in the next level, level 2, so we were at level 1, now are at level 2. So current level is level 2. Level 2 means we have to visit the even levels. So in this we can see, first we will see 3, whether 3 is greater than the previous value or not. So 3 is greater than previous value. Condition 1 is satisfied. Condition 1 is satisfied. Now we will see whether 3 is odd or not. 3 is odd. Hence it is satisfying both the conditions. So we will update the previous value with 3 and we will insert the children of 3 to its odd level queue. Children of 3 is 12 and 8. And we will pop this element from the queue. Next element is 7. So is 7 greater than 3? Yes, it is greater than 3. And is 7 an odd number? Yes. So both the conditions are satisfied. So now we will insert the children of 7 in the odd level queue. Children of 7 are only 6. So we will insert 6 and we will pop this and update the previous value with 7. Now the next element is 9. So is 9 greater than 7? Yes, it is greater than 7. And is 9 an odd number? Yes, it is an odd number. So both conditions are satisfied. And now we will push the children of 9 to odd level queue. So there is no left children. Now we will push the right children in the queue. Now we will pop this element from the queue and we will reset the previous value. Now we are at level 3. At level 3, we will first check whether 12 is less than previous value or not. So we can see 12 is less than infinity. So first condition is satisfied. And this element is even or not. So 12 is an even number. So second condition is also satisfied. So we will update the previous value with 12 and pop this element from the queue. So we will pop this element. Now the next element is 8. Is 8 less than 12? Yes, it is less than 12. And also is an 8 an even number? Yes, it is an even number. So both conditions are satisfied. We will update the previous value with 8 and we will pop the element from the queue. Again, now the next element is 6. So 6 is also less than 8 and 6 as an even number. So both conditions are satisfied. We will update the previous value with 6 and pop the element from the queue. Now we have 2. Is 2 less than 6? Yes, 2 is less than 6. We will update the previous value with 2. And is 2 an even number? Yes, it is an even number. So all the conditions are satisfied for this queue. So since we don't have any children, we haven't inserted anything at even level queue. So at the end, now we can see both the queues are empty and we haven't violated any conditions till now. So we can say that by this binary tree, all the three conditions were satisfied. So in that case, we will return true. And the output was also true. Let's take another example and see. So initially, in this example, we are at current level 0 and we have the values 5 in the queue. So first condition. So the root is at level 0. First condition satisfied. Now, is 5 greater than minus infinity? Yes, it is greater. And is 5 an odd number? For even level, the values must be odd. And for odd level, the values must be even. So 5 is greater than minus infinity. So it is satisfied and it is an odd number. So both the conditions are satisfied. We will pop this element and push the children of 5 in the odd level queue. So we will push 9 and 1 and pop this element from the queue. Now we are at the next level, level 1. So at odd level, the values must be even. So we are seeing that 9 is less than plus infinity. First condition is satisfied, but 9 is not even. So second condition is not satisfied. So then and there, we will return false and we will not check any further conditions. So since one condition is violated, we can return false for this example. So the output is false. Let's take another example and see. Example 3. So at even level, the values must be odd. And at odd level, the values must be even. Initially, we have 5 in the queue and we are at level 0. So level 0 is an even level. So we will visit the even level queue. So we will see whether 5 is greater than minus infinity or not, since we need strictly increasing. Yes, it is satisfying. And whether 5 is an odd number or not. Yes, it is also satisfied. So both the two conditions are satisfied. We will push the children of 5 to odd level queue. So children of 5 are 4 and 2. Now we will pop this element from the queue. So this even level queue is now empty. We will increase the current level and now we see current level is odd. So we will visit odd level queue And in this, we need the values in strictly decreasing order. So is 4 less than plus infinity? Yes, it is. Is 4 an even number? Yes, it is. So both the conditions are satisfied. We will push the children of 4 in the even level queue. Children of 4 are 3 and 3. Now we will update the previous value with 4 and pop the element from the queue. Next is 2. Is 2 greater than 4? Yes, it is. And is it an even number? Yes. So we will update 4 with 2 and we will insert the children of 2 in the even level queue. Children of 2 are 7. Now we will pop this element from the queue. So we can see now odd level queue is empty. We will increase the level by 1 and update the previous value with infinity. Now in the even level queue, the values must be odd and it should be strictly increasing. So is 3 greater than minus infinity? Yes. Is 3 an odd number? Yes. So this condition is satisfied. Now we will push the children of 3 inside the odd level queue. Since we don't have any children, we will not push anything in the odd level queue. Now we will pop this element from the queue. Before popping, we will update the previous value with 3. Now we can pop it from the queue. Next element is 3. Is 3 an odd number? Yes. Is 3 greater than 3? Because strictly increasing means it cannot be same. It must be greater than the previous value. So 3 is not greater than 3. That means this condition is not followed. So since any of the condition is violated, we will return false then and there. We will not check anything further. So in this case, we will return false at this point of time. And we can see the output of this example was also false. So I hope by this examples, we have understood the solution. So basically, what we will do, we will take two queues, Q1 and Q2. One will indicate the odd level queue, other will indicate even level queue, and we will keep a current level variable which will indicate at which level we are at. Is it an odd level or is it an even level? If we are at odd level, we will visit the odd level queue. If we are at even level, we will traverse the even level queue. And once we will, and while iterating this queue, we will pop the elements, and before popping, we will check all the two conditions, condition 1 and condition 2, whether it is an even number and is it an strictly greater than or not. Similarly, for Q2, we will do the same. So once we traverse all the tree and all the conditions are satisfied, we will return true, else we will return false. Let's try to code and see. So we will take two queues and we will keep the address here. One will be odd level queue. Similarly, we will take another queue which will be an even level queue. Now in even level, since we are starting with the level 0, so level 0 is even level and we will push the root node inside it. And initially, the current level will indicate will be 0. So if current level is 0, now till when we will be iterating the trade until we will find the odd level and even level queues are empty. So we will check this condition level dot empty or level dot empty. So this condition will see whether both the queues are empty or not. Now we will see at what level we are at. If current level is equal to 0, that means we are at odd level. That means it is an odd level. Sorry, if current level is 0, that means it is an even level. Current level is 0, that means it is an even level. And inside this, we will write previous value as int min. So we can see in even level index, we want the values to be strictly increasing. So we can keep the previous value as in minus infinity. Now we will iterate the even level queue until it is not empty. Level dot empty. Now we will pop the element one by one from the queue. So even level dot front, even level dot pop. If this node value, current node value, if this current node value is odd, at even level, we want the values to be odd. So we will check if this values is even or it is less than or equal to current value, that is node val. And that means either condition one is either condition one is not satisfied or either condition two is not satisfied. In that case, we will return false, right? Else, we will update the previous value with the current value if it is satisfying both the condition. So now if it has satisfied both the condition, we will check whether we have left children or not. If we have the left children, we will insert that node in the odd level queue. Similarly, we will check whether we have the right children and we will insert the right children in the odd level queue. So once we have visited all the nodes from this queue, we will change the level. Now the current level will be an odd level. That is next level. So next level will be 1 minus current level. That means if the current level is 0, if the current level is 0 and we do 1 minus 0, it will give 1. If the current level is 1, then we will do 1 minus 1, it will give 0. That means from odd, we are switching it to even, and from even, we are switching it to odd. That's what we are doing here. Now, if the current level is, so this was if the current level is even. Now let's see what if the current level is odd. Else, we will do the same exact thing, but we will change the conditions inside it. So now, since at odd level, we want strictly decreasing, we will initialize it with int max. And odd level, we are going to visit odd level queue. we will see the element one by one from the front, and we will pop the element from the odd level queue. And in the odd level, the values must be even. That means if the value is odd or it is less than equal to node val, in that case we will return false, else we will update the previous value with the current value. And if we have the left children, we will push into even level queue, and we have the right children, we will push into even level queue. So in this way, we can satisfy both the condition for odd level as as an even level. If all the conditions are satisfied, then we will return true. So we are returning false if any of these conditions are not satisfied, and we are returning false if even of this condition is not satisfied. That means if a binary tree is violating any of the conditions, we are straight away returning false. Else, we will return. At the end, we will return true. Let's try to submit the test cases. So here it is written. Let's see what is the error. Okay, it's previous val. So we might be getting error here also. Pre-val. Here also pre-val. And let's try to resubmit. So the test cases has been accepted. Let's try to submit the solution. So the solution is accepted. I hope the solution is clear to you all. If you have any doubts, mention in the comments below. See you in the next video. Thank you.